You bring home a beautiful new houseplant. You place it by a bright window, you water it perfectly on schedule, and nothing happens. Months go by, and it hasn't grown a single new leaf. This illustration from Vinayak Garg's book shows us why. The plant acts like a chef, using light and water as ingredients to create its own food through photosynthesis. But that process mostly just creates sugar. It gives the plant the basic calories it needs to survive, but not much else. Think about your own diet. If you drank nothing but sugar water, you would technically have energy, but you wouldn't be able to build muscle, repair tissues, or stay healthy long-term without protein and vitamins. Plants operate the exact same way. To actually construct new leaves, stems, and roots, they have to pull physical ingredients out of the dirt they sit in. If you look closely at a bag of potting soil or plant food, you'll almost always see three prominent letters: N, P, and K. Those letters represent the plant world's version of primary nutrients, the essential diet required to turn solar energy into actual physical growth. Let's break those down. The first letter, N, stands for nitrogen. In the plant world, nitrogen is the equivalent of protein. It is the ultimate bodybuilder. The plant uses nitrogen to produce chlorophyll. That is the pigment it uses to physically construct large, vibrant green leaves. If you want a lush, leafy canopy, your plant needs plenty of nitrogen. The second letter, P, stands for phosphorus. You can think of phosphorus as carbohydrates. It acts as the plant's energy manager, deciding where the calories from photosynthesis should go. Phosphorus directs that energy downwards, using those carbs to push into the soil and build a structural root system. But when the time is right, it channels that energy upwards to the plant's tips, producing flashy features like blossoms. Together, nitrogen and phosphorus are the primary architects of your plant's physical form. They build the visible green leaves above and the invisible structural foundation below. That brings us to the final letter, K, which stands for potassium. If nitrogen is protein and phosphorus is carbs, potassium is your daily multivitamin. Potassium physically strengthens the plant's cell walls. It acts as an immune system, reinforcing the plant from the inside out, so it can fend off diseases, survive dry spells, and handle sudden drops in temperature. So we have N for lysi protein, P for root and flower carbs, and K for immune vitamins. But plants don't have stomachs. They can't just swallow these nutrients directly from the fertilizer. Instead, they rely on the soil itself. The microorganisms and fungi living in the dirt act as the plant's digestive tract. They chew up the complex NPK molecules into tiny, bite-sized pieces that the roots can easily absorb. This means these main nutrients are useless without healthy soil to process them. The microscopic ecosystem in the dirt is as important as the fertilizer you pour on top. Once you understand these three letters, those confusing numbers on commercial plant foods suddenly make sense. You'll often see a set of numbers on the bottle, like 10, 10, 10. An equal ratio like that indicates a balanced maintenance diet. It provides even amounts of protein, carbs, and vitamins for a plant that is already sitting naturally healthy in its pot. But let's say you have a leafy houseplant, like a monstera, that is looking pale and yellowish, and its growth has entirely stalled. Knowing the plant's diet, we can prescribe the right solution. You would look for a fertilizer with a higher first number, a nitrogen-heavy mix to help it rebuild those vibrant green leaves. Or perhaps you have a mature plant that is perfectly green and bushy, but it absolutely refuses to bloom when the flowering season arrives. That plant needs a fertilizer with higher second and third numbers. A boost of phosphorus and potassium will trigger that blooming process and support the high energy required to maintain flowers. Understanding the NPK system transforms the intimidating task of soil chemistry into simply reading a familiar nutrition label, allowing you to give your plant babies exactly what they need to thrive.